Scheduled background jobs. Now we're going to continue our job discussion from the previous nugget, but we're going to play around with a new type of job that was added to Windows 8. Actually, it was added to PowerShell version 3, but I'm going to show it to you in Windows 8. That lets you have a job that can run even when PowerShell isn't running. In fact, you don't even have to be logged onto the computer, but you still work with the job and its results entirely within Windows PowerShell. So we'll start with a quick overview of what these scheduled jobs are and kind of contrast them to scheduled tasks. There's two different things, both of which involve the task scheduler functionality in Windows. We're going to be focusing on this one, and I really want to make sure that you understand the difference so you don't accidentally start using the other one and wonder why it doesn't work the way I show you. We'll also talk about some version information, what this works with, what it doesn't work with. From there, there's really three main types of objects we need to play with. The triggers that determine when a job runs, the options that control some elements of its behavior, and the job itself. Now, once we get a job set up and running, I'll show you how to work with the results of that job, how they remain cached on disk, how you can get them out, and how you can maintain those results so that it doesn't grow and suck up all the space on your hard drive. Now, in this nugget will be entirely in PowerShell version 3 and later, because the features I'm going to be talking about are actually, you know what? It's a good time to clear up a little bit of confusion here. Let's do a get module minus list available. Let me see if I can format this list in a wide list so we can get more of it on the screen at once. Yeah, okay. So there's a module called scheduled tasks. That is not what we are going to be playing with in this nugget. The scheduled tasks module, I believe, does require PowerShell version 3, but it doesn't ship with PowerShell version 3. It's part of the operating system. So with this version of Windows and later, I get a scheduled tasks module, and that actually allows me to administer the scheduled tasks functionality on this computer. I don't think I copied it over to, yeah, I did, task scheduler. Right, so that scheduled tasks module lets you put stuff into this task scheduler. It really has nothing to do with PowerShell, and it has nothing to do with PowerShell jobs. I mean, yeah, you use it within PowerShell, but it gives you a lot of the same functionality as if you ran the scheduled tasks command. So that's what we're not going to be talking about. I only wanted to point it out because there's some naming overlap with the, wait for it, PS scheduled job module. That is a feature of PowerShell version 3, which means if you have PowerShell version 3 installed on, let's say, Windows 7, you'll get the PS scheduled job module. So everything I'm going to be showing you works in PowerShell 3 and later, no matter what operating system you have PowerShell 3 or later installed on. So let's go ahead and do a get command. PS scheduled, oops, I don't know why I put a dash there. PS scheduled job, waiting for tab completion. Not going to happen. There we go. That's what I wanted. And let's also really quickly talk about the architecture of this thing. Let's talk about what it does. You've got PowerShell over here, PowerShell, and you have the scheduled tasks functionality in Windows, the task scheduler. And you've also got storage over here in the form of disk. Now, what the PS scheduled job module lets you do is tell PowerShell to create a task in Task Scheduler. You're going to tell it what PowerShell command to run. The scheduled tasks will be set up in such a way that they run PowerShell, they run whatever commands you told it to, and the results get cached to disk in, it's basically an XML file. When you open PowerShell, it scans the disk, presents any results as a job, just like the jobs we worked with in the previous nugget. And to see the results, you run the receive job command. So you're going to receive the results into the pipeline. Now they remain cached on disk when you do that, and you're going to see there's some options we can use to control how many past executions of the task remain cached on disk. So the scheduled tasks module, which I pointed out first, really just lets you set up a scheduled task. It's a normal scheduled task, nothing special happens. PS schedule job lets you set up a scheduled task that, once the task scheduler runs it, will appear as a job in Windows PowerShell. So you really administer this thing entirely from within Windows PowerShell. It's just using scheduled tasks kind of in the background, really, to run the thing. And that means that PowerShell doesn't actually have to be open when the job runs, but PowerShell will still see the job results. So this is a very different type of job, and it definitely plays to the fact that, like I said in the previous nugget, jobs are an extension point in Windows PowerShell. This is a new type of job. With the other jobs I showed you in the previous nugget, local jobs, WMI jobs, and remoting jobs, the job only exists while PowerShell is open. If you close the shell, you lose all your job results. These scheduled jobs don't work quite like that. They go ahead and use the disk subsystem kind of in the middle so that it can cache those job results, which means you can open a brand new copy of PowerShell and still see job results if they're sitting there on disk for you to look at. So we've got a few commands that we're going to play with here. The big one, I guess the first one we'll start with, is job trigger. Now that's going to let us define a trigger which will determine when this thing runs. Daily, automatically, at a certain time, whatever. We've got a lot of triggers to work with. We've got some scheduled job options as well, things that define some characteristics about this. So we're going to set those things up, and then we will register a scheduled job. Now the scheduled job has to come with a trigger and can come with options. So we'll do this first, do this second, and once we've got our trigger and options, we'll actually register the job. That'll give it over to Task Scheduler. Now from that point, you can get a list of scheduled jobs, you can get a list of defined options, you can disable or enable a scheduled job to temporarily turn it on or off. You can set it, which means changing the configuration of an existing one, and you can unregister it, which removes it completely from the task scheduler, so it's not defined there anymore. We're going to play around with these first three, though. I want you to know that these other ones exist. They're all there to let you work with something once it's already defined, but we're going to focus on actually getting this little booger defined so that we can play with it. So let's clear the screen and get ready to go. So I'd actually like to start by looking at the help for new, job trigger, was it, right? New job trigger. Yes. Okay. So it's important. The reason I'll mentally flub the command names from time to time is because the scheduled tasks module, the one we're not working with right now, the command names are very, very similar. So you need to make sure that as you're reading the help, it's referring to things like scheduled job. So here's some of the things that we can do in terms of creating a trigger. You've got 5 different parameter sets here. So you can create a job trigger that runs at startup, right? Runs automatically when the thing starts. You can impose a random delay on that. And that's just to kind of break up exactly when this runs. You'll notice they all have the random delay parameter in there. You can have it run every time a user logs on. This is actually, as we start to try and move away from things like logon scripts, this is a way of getting some of the functionality that you might have had from a logon script, something that's going to run in the user's context. You can have this run daily, so you specify every so many delays at whatever date and time you want. You can have it run weekly on whatever days of the week at whatever date time, every this many weeks. That's a good way to get it to run every other Monday. So you would say run weekly, week interval 2, so every other, at whatever time on Monday being your day of the week. And remember, 2 square brackets means you can specify multiple values. So you can have this run on multiple days of the week on a weekly basis. And then finally, you've also got run once. Although that's a little misleading, you can also have it say run every hour, run once every hour, or you can have a different repetition interval. So how often do you want it to run at whatever date and time? So you've got lots of triggers that you can actually set up. I am going to, let's see, let's do a run at logon, because that's something I can control pretty quickly. So we're going to set up a trigger equals new job trigger. I'm going to run @logon, and we're going to put a random delay of, oh, actually it's not. I want this to run kind of immediately when I log on, so let's not do that. What user do I want this to log on as? This is where we should really go back and read the full help and see what maybe the defaults are. So let's look at that -user parameter. Specifies the user whose logon triggers this. Enter the name of a user, or enter asterisk to represent all users, and the default is already all users. So that's good. So trigger equals new job trigger @logon. And that's really all I need to do. I don't want a random delay. I want it to run for all users. So, boom. Let's take a look at that object that we got created. The wonderful thing about triggers. So this is going to run @logon. It is an enabled trigger. Now you can go back and disable this trigger. And one of the neat things is, when you look at register scheduled job, you do have to provide it with a trigger, but you can provide multiple triggers. So you could have one trigger defined to run @logon, another trigger defined to run every hour, I don't know, whatever you crazy kids do these days. So you can have multiple triggers kicking off this job, but you can disable or enable those triggers independently. So if you needed to stop the hourly run, you could disable the hourly trigger while leaving any other triggers still registered. So that's our trigger. Now let's take a look at new scheduled job option. We'll go ahead for the full help, but I'm going to leave it paused. A lot simpler to use here because it only has a single parameter set to play with. You're basically just going to specify the switches that you want to be true. Do you want this to continue if the machine goes on to battery? Do not allow this to be started on demand. Only allow it to be started when one of its triggers go off. Do you want to hide this in Task Scheduler so that no one can see it? What is the idle duration and idle timeout that you want to specify? Do you need this to be connected to the network? Do you want to wake the computer? Do you want to stop this if the computer is about to go on idle? Do you want to allow it to start if the computer is on battery? Do you want to allow it to start if the computer is idle? Does it need to run under elevated permissions? And when you resume from idle, do you need it to restart? So you've got a lot of different options you can specify. You don't have to specify any of them. Don't have to specify any of them. I'm going to put one in here just so we've got something to play with. Call this option equals new scheduled job option, require network, and wake to run. So let's take a look at that option object. Really just lays out all the options that I've set up. So I've set up, this is going to, because there are some defaults, this is going to stop if I go onto battery. It will wake to run, I specified that. It will start if the computer is not idle. That's a default. We define idle as the computer having been idle for 10 minutes, and I've got a 1-hour timeout on there. Default is to show in Task Scheduler. So, okay, good enough. So now we've got a trigger and an option that we can play with. Now it's time to actually sit and start registering and creating our scheduled job. So that's going to be the register scheduled job command. Now, you can give your job a name. Actually, you must give your job a name. You'll see that this is a mandatory parameter, and you also have to give it a script block, which is the command you want to run. You can feed some arguments into that script block if you want to. You can provide an alternate credential for this to run under. It can run a little initialization script before it kicks off. Here's an important thing, max result count. How many sets of results do you want cached to disk? And once you set that, it will automatically rotate out, delete the oldest set of results every time you run this to make room for new sets of results. You feed it your job option object and your trigger object, and you're good to go. The only difference between this first parameter set and the second one is really right here. Instead of providing a command to run, you provide the path to a script to run. Otherwise, these things are the same. So let's just get one going. Register scheduled job, name, get processes at logon. Not sure why you would want to do that, but that's what we're going to do because it's something I can make happen quickly and on demand. Don't need an argument list. I don't need authentication. I do need a script block. Remember, script blocks go in curly brackets, not in quotes or anything else. Let's set a max result count of 2. And keep it small, again, so it's something I can demonstrate without this having to go on forever. Trigger is going to be my trigger job, or my trigger object, and option. Scheduled job option will be my option object. Let's hit enter, see what happens. There we go. Get scheduled job. I've got one scheduled job on there. It is enabled. Let's actually get all of the data we can for this. There's a definition object. There are option and trigger objects. You'll notice there's one trigger listed. I would have to expand that property in order to see those. So do something like select, expand job triggers. That will show me the triggers associated with that. It has a name, everything else. It's real quick. Pop open scheduled tasks or task scheduler or whatever we call this GUI console these days. And, oops. Well, actually, I didn't mean to close PowerShell, but it's something I was going to have to do anyway, so I guess it's important that that happened. Let's take a look here. I'm so used to doing this from the command line that the GUI doesn't even make sense. So we've got our overview, we've got tasks that have run. I want active tasks. So these should be roughly alphabetical-ish. There it is. Get process at logon. So you can see that PowerShell has actually done this for me. It's running PowerShell. So it's going to run everything from within the shell. So let's actually close this. Now, real quick, before I make this thing run by logging off, I want to show you something that has changed in PowerShell version 4. So, help, register, scheduled job. You get a new parameter called run now. There's also run as 32, which means this will run it in a 32-bit shell process instead of 64, but you get run now. And when you specify run now, there's no need to specify a trigger. It will just run it now, right now, immediately, now. So I could have used this. This is actually great for doing a demonstration, but we're not gonna. So let's get back over to PowerShell version 3. I'm going to log out of this computer. I'm actually, how do I do that? There we go. You know, I hate that. I'm going to log off of this computer, and that's going to disconnect me. So I'm going to go ahead and pause. I'll get reconnected, and then we'll check and see if this thing actually ran. So here we go. And through the powers of movie magic, we're back. Let's go to the desktop. Now, these scheduled jobs do run at logon, but you know the logon process can take a second. Sometimes you'll get the start menu or start screen available while there's still stuff happening in the background, which is why I'm talking to you now, to give it time to finish. Okay, let's see if it's done. Open up PowerShell, brand new shell window. No reason there should be any jobs. I haven't run any jobs, and when I run get job, there aren't any jobs. Here's the trick. The type of job I'm working with isn't native to PowerShell. It was added by a module. So until I import that module, I can't see the job. But once I do, there's the job. It was my, here, you know what? Let's format this as a list. It was my get processes job. So the command it ran was get process, the name of the job, get processes at logon. It completed, it began then, it ended then. So, oops, I forget what the job ID was. Was it 2? Yeah. Receive job ID 2. Because look, it has more data. So there's clearly something there for me to receive. There's my process list. Get job. Does not has more data, right? So it's not going to persist that information once you receive it. If you wanted to receive it and keep it cached, you would actually have to tell it minus keep on the received job, right? Just like we did in the previous one. Let's open that back up. New thing, import module, PS scheduled job, get job. Still shows me the results, and look, it actually did keep it on disk. I think I mentioned that earlier. Receive job ID 2. It stays on disk. It just, when the shell looks at it, it brings that information into memory, and it doesn't cache it in memory. But if you close the shell and go back in, the disk file is still physically sitting there. So let's close this down. I want to show you where you can go find these disk files, just to kind of prove they exist. You can, let me size this window a little better. The clue to where to find these is to actually look at the scheduled job itself. You see that big path at the end there under the execution arguments? That's where my job definition and the output are going to live. So I'm going to cd to my home folder, go to app data, local, Microsoft, Windows, PowerShell, scheduled jobs. There's my get processes at logon scheduled job. There's the job definition, which is an XML file, and my output. There's the output from that particular date timestamp. There's the results, XML file, and the status. If we just look at this, it actually is XML. It's XML. There's a lot of it. I don't want to look at it. If I want to receive those results, I do it with the job command. They know how to receive that. Now the trick is, I think I set this to have a max execution or max output of 2, which means I should never have more than 2 folders. So let's see what happens. So I logged off, log back on. Let's see, cd app data, local, Microsoft, Windows, PowerShell, scheduled, cd get, cd output. There's the second one. So I've got 2. Here we go again. You ever wonder if your computer gets tired? You know how you get tired of users that just do the same thing and expect something different every time? Do you want to be logged on or not? It's not going to be any different the next time, man. cd app data, local, Microsoft, Windows, PowerShell, scheduled, get, cd output. Still only 2 because the old one went away. It went away as soon as the new one ran. So it's going to limit this to 2. So that sort of proves that works as well. These are really, really useful little creatures, these scheduled jobs. Keep in mind they're defined on a per computer basis. So this is something great to do with a server where you need some PowerShell command to run. You need it to run even if no one's logged on, which Task Scheduler can do. But you want to be able to work with the output in Windows PowerShell. This kind of gives you the best of both worlds. It lets you play with Task Scheduler, but do so in a very PowerShell-friendly fashion. If you were to just come into Task Scheduler and set up PowerShell to run a command, you would have to worry about how to capture the results, where they were going to go, everything else. This way, it's kind of all automatically done for you. So there you go. A good quick overview of these scheduled jobs. And remember, they're not the same as scheduled tasks. That's a separate thing, although both of those do utilize the Windows Task Scheduler functionality. The jobs just do it from kind of entirely within PowerShell. You define a trigger that says when the job will run. You set some options about its behavior, and then you register the job, including the command that you want it to run. Any results of that will be cached to disk, and I showed you how to work with those results once the job is actually run. I hope this has been informative for you, and I'd like to thank you for viewing.